Hello friends, welcome back. Let us solve problem set 3. As usual, we are just going to discuss the problems and you are going to solve the problems. I am not going to solve each and every problem on the board. So let us start with this. The first example, draw the perpendicular bisector of segment AB of length 8.3. Very simple. Draw length 8.3 AB and draw perpendicular bisector. How to draw perpendicular bisector we have already seen. Second, draw an angle of 125 degrees and bisect it. Draw angle and just draw the angle bisector. I think the first few examples are just for the revision of the previous standards. Construct triangle element such that LM is 6.2, MN is 4.9 and LN is 5.6 centimeters. 3 sides are given. Start with the base. On both the sides, draw arcs. Wherever it cuts, your third point is there. Very simple. Don't forget to write the measurement of the lines on your final figure. Write units also, that is centimeters. Fourth example, construct triangle PQR such that PQ is 5.7 and angle P and Q are 50 degrees. Two angles are same, so two opposite sides are also same. This is isosceles triangle. Very easy to construct. Draw the base first, two angles where the rays will intersect. That will be your third point. Fifth one, construct triangle DEF such that D is 6.5, E and F are 30 degrees. Draw EM perpendicular to DF. Measure the length of segment EM. You have to draw one triangle. Let us see the rough figure for this. DE and F is here. This is the triangle. The given is DE is 6.5 given. 6.5 DE is given. Then angle E and F are 50 and 30. E and F are given. F is 30 and this is 50. Now how will you solve in this case? First of all, you have to find out what this angle is. Okay, because baseline is 6.5 given, one angle is given. I want this angle. Only then I can draw the triangle. So 180 minus 80. So this will be 100 degrees. Okay. Then they are asked to draw EM perpendicular to DF. DF, you have to extend this and you have to draw EM perpendicular to this and measure the length of segment EM. So measure the EM. Now here the answer is measurement of EM. Of course figure is important, drawing the figure. At least half of the marks goes to the figure, but measuring this side is also important. So measure and write down what is the size of that side. Next, sixth, construct triangle LEM such that LE is 6, LM is 7.5 and LEM is 90 degrees. This is a right angle triangle. You can easily draw this and draw the circumcircle of this triangle. Circumcircles, C, that is PC. So perpendicular bisector of any two sides. Construct triangle, seventh one, construct triangle DCE such that DC is 7.9, C is 135 and D is 20 degrees. Easy to construct. Base is given, two angles are given. It's 135 means obtuse angle triangle is there, and draw circumcircle. Simple. Perpendicular bisectors to any two sides where they will intersect. You will have center of the circle. Take the radius to any vertices and you will get the circumcircle. Construct the in circle of triangle SGN such that SG is given 6.7 and S and G angles are given 70 and 50. So base, draw base, two angles, you will get the triangle, and now you have to draw in circle I, that is AI, angle bisector of any two sides. You have to draw angle bisectors of any two sides. So point of intersection will be the center of the incircle. Now you have to find out the radius. How will you find out the radius? Draw perpendicular to any side. Okay, to any side, perpendicular to side through point outside. This is the method you have to adopt. And so you can draw incircle. Ninth one, construct the incircle of triangle SRN such that RN is given 5.9, RS is given 4.9 and angle R is given 95. So RN is given, angle R is given and RS is given. So you can easily construct this triangle and then draw incircle. So angle bisector of any two angles and you will get the center of the circle. After that you have to draw a perpendicular to any side to find out the radius. They may ask you to write down what is the measurement of radius also. Just read the problem carefully. Here they have not asked, but they may ask. Construct DAT such that DA is 6.4, D is 120 degrees and A is 25 degrees. Draw incircle. Similarly, 11th, draw a circumcircle and incircle of equilateral triangle with side 6.6. 6.6 side is there. You can easily draw equilateral triangle. All sides are equal and you have to draw circumcircle and incircle both. So when both are to be drawn, be careful while for the construction lines. Those arcs may get mixed up. Okay. 13th, draw a circle of radius 3.6. Take any point M on it. Draw tangent to the circle at M without using the center of the circle. Now here you don't have to use the center of the circle. That means alternate segment, angles in the alternate segments are congruent. That property you have to use. This 3.6 radius is given. Take any point M on it. So first draw any triangle. Okay, any triangle. Now this, draw a congruent angle to this angle, as this is the one arm and then second arm. Here you will get this, extend this line. This will be the tangent to the circle at point M or at given point. Remember one thing, whenever the center is not to be used, you have to use the alternate angles in alternate segment. Next, draw a circle of suitable radius. Any radius you can draw. Draw a chord XY of length 4.6. Whenever any radius you have to draw, just draw a proper size circle, okay, such that your chord should not go at the end of the circle somewhere. So take a circle properly. Draw tangents at the point X and Y without using center of the circle. Now here you have to use two congruent angles. One chord is there, complete the triangle, and so we have to use the angles in alternate segment. Example 15. Construct tangents to the circle with center A and radius 3.5 from a point B at a distance of 7.3 from the center. Now they have given the radius of the circle 3.5 centimeters. Sometimes they may give that the diameter of the circle is 7 centimeters. Okay, and the point B is at a distance 7 centimeters from the center. Now it's confusing because you have habit of considering the radius of the first circle. See, whenever you are solving these examples, when everywhere radius is there, and suddenly when diameter comes, many students get confused. So be careful whether the radius is given or diameter is given. If diameter is given, then half is the radius. Okay. So in this case, 3.5 is the radius. So you have drawn one circle of 3.5. Center is given O, and at point 7.3, the point B at a distance of 7.3. So how will you solve this? inscribed angle in semicircle is right angle. So you have to draw perpendicular bisector to OB, and from that is your center of the circle, bigger circle, and this as a center you just draw a bigger circle, and the point of intersection, this point and this point, we connect these 2 points, and these are your tangents. Example 16. Draw tangents to the circle with center P, radius 2.9 from point Q at a distance from 8.8. Similar to the previous example, the Q lies on the line containing the diameter. Same. Nothing different is that. You have to just extend the diameter. That's all. 17th. This was in the July 15th exam for 5 marks. Bonus. Because triangle ABC and triangle LMN, no vertex are same. Common vertex is not there, and those triangles are similar triangles ABC and LMN. In ABC, AB is 5.1, B is 55, C is 65, and AC upon LN is 3 by 5. So here you have to go by the calculation method, analytical methods you have to go, not by graphical method or construction methods. Very simple. Very simple, okay? And you have to construct triangle LMN, 5 marks. It's really a bonus example. You have to just find out one side because 2 angles are given. 2 angles are given. You have to just find out one side. And for that they are giving 5 marks. Good. 18th example. XYZ and DEF are similar triangles. Same as previous one. XYZ, DEF. No common vertex, so you have to go by calculation method, analytical method. So in the DF, D is given, angle E40 is given, and EF4 is given, and ratio 6 by 5. Construct triangle XYZ. Very simple. Then construct circumcircle of triangle ABC such that AB is 5, AC is 12, and BAC is 90. Right angle triangle, very easy to construct. And circumcircle you have to draw, so you have to give C, that is PC, perpendicular bisector of the sides. Let us now solve the 28th, the last example of the problem set 3. Now this is interesting example, and I think this is the toughest example of this whole chapter. Okay, let us see why. In triangle PQR, angle Q is 90. Okay, first of all draw the rough figure. In triangle PQR, P, Q and R, Q is 90 degrees, they are given. Segment QM is the median. Segment QM is the median, that means this is M. QM is the median. Then they have given PQ square plus QR square. PQ square plus QR square is equal to 169. Draw a circumcircle of triangle PQR. Now first of all, only right angle is given, no measurements are given, some equation is given. So how will you draw the PQR first? That is the problem. Okay, this is median, so this side equal to this side. Now we have to find out the at least one side first. Only then we can draw the triangle and then circumcircle. So here can we use the Apollonia theorem? Very simple. In Apollonia's theorem, what you can say, PQ square plus QR square is equal to 2QM square plus 2MR square. PQ square plus QR square is equal to 2QM square plus 2MR square. This is the Apollonia's theorem, if you remember. Now one more thing we know, that this is a right angle triangle and the median to hypotenuse is half of the hypotenuse. This we know. That means these 3 sides are equal. Correct? QM is equal to MR. Can we substitute here? QM is equal to MR. So we got 4QM square is equal to PQ square plus QR square, we know 169. So we can easily find out QM square is 169 by 4. So QM is equal to 13 by 2. So this QM is 6.5 and MR is 6.5, PM is 6.5, so this is 13. PR is 13. Now you can draw this triangle because you know one side. Okay, so we draw PR first, 13. You have to find out the point M. So by the geometrical method, that is by construction method, by taking the perpendicular bisector of the PR, you find out where is the point M is. Okay, now you know MQ is 6.5, but can you see that this is the right angle? If this is the median, if you take this as center and draw a semicircle, this right angle is inscribed angle in semicircle, correct? So by taking M as a center, I will draw one semicircle. Now I know where MQ is 6.5 away from M. So in the compass take 6.5, cut this semicircle, that will be your point Q. So suppose the point Q you got here, join this and you will get the triangle PQR. Once you get the triangle PQR, then it is very easy. You have to draw the semicircle. So PC, perpendicular bisector of any two sides. Now the perpendicular bisector of PR we already found out. The line is there. Light construction line you must be having here somewhere. So draw the perpendicular bisector of any one of these two sides, and suppose you draw the perpendicular bisector of this side, we will get somewhere here, circumcenter, and taking the distance radius to that vertices, suppose this is O center, any of the vertex is your radius, you draw circumcircle. That finish your example. So this is also not very difficult example, just you have to think a lot here. But this was the toughest example in the whole chapter. All other examples were so easy, but this is something different. So here we are finishing problem set 3, and along with that we are also finished the chapter 3 geometric constructions. Chapter 3 geometric construction is not difficult at all. Okay, though some problems may come like this, but it is not difficult at all. The only thing, your expertise in construction are of utmost important. So please be sure that you are not doing any manipulation work. Your drawing or your instrument box first of all is perfect, and then your drawing the points etc. are perfect. At the end of the construction, don't forget to in short one line or in some point wise you draw how you constructed this figure. Okay, give proper. Now here I have written only 6.5, but you should write 6.5 centimeters. If angle is there 60, then don't write just 60, write 60 degrees. Okay, wherever the rays are there, extended lines, show the proper arrows because that is a ray. Okay, name each and every point of the figure, and don't forget, last but not least, don't forget to read carefully what is asked. Now in this problem, if they are asked to draw the circumcircle and measure the radius, and if you forget to measure the radius, to write the radius of the circumcircle is so and so, then your half of the marks will be cut because you forgot. Though your figure is perfect, everything is perfect, but your answer you are not written at all. So half of the marks will cut. Maybe few marks, 1 or 2 marks will get for the steps. So this chapter itself is very easy. Practice as many examples, as many constructions as you can. Start with the basic constructions, whatever you have seen in the introductory topic, and then go ahead. Go through the previous year papers, find out what are the examples they are asked on this chapter, solve those examples, so it will be very easy. So friends, here we have finished the chapter number 3, geometric constructions. Thank you very much.